Good morning, everybody. We'll begin today's session. So this is the first question. A light source is attached to a rod fixed in the center of a ceiling of a square room. The source rotates 360 degrees with the rod at its axis. The source projects a red beam of light onto the four walls of the room. The setup is shown in the isometric view and the side view in the figure below. You have to identify the correct path of the beam of light on the four walls of the room. Okay, to identify what the light path traced by the beam. So here we are given a 3D view, which is an isometric view. And then we are also given the side view of the light source and the room. It's a square room, which is given, and the light source is bang in the center of the room. Now, we have to identify the path traced by the light source on the wall of the room. So if this is the wall of the room, and the light source is pointing to the middle part, it will be at the shortest distance from the ground. It will be at the largest distance from the ground. But then when it goes away towards the corner where the distance between the center and the corner increases, at that point in time, it drops down a little bit. So the path trace will be like an arc formed here where the center is at the peak and then the corners are a little bit down. So this path will be continuing across because it's a square room. Henceforth, all the walls will look at like the same. The light rays on all the walls will be the same. So the correct answer here will be option A. We'll move to the next one. The figure below shows the top view, front view, and side view of a three-dimensional solid object. What is the minimum number of surfaces that a solid with these views can have? You have to assume that there are no hidden lines. All right. So here we are given here top view, front view, and side view of a solid. We have to identify what's the minimum number of surfaces that a solid can have. Now, in this kind of an organization, one can assume that this is a simple cube, okay, that is getting formed. And then the surfaces that are there, they look like this. So top looks like this, side looks like this, and this side looks like this. Now, one way to say is that, yes, there will be corners, but we can reduce the corners by this kind of an element called a pendentive. Pendentive, a pendentive, okay? So a pendentive is basically a three-dimensional curve that allows you to transfer load from 2 points in the middle, which helps in transferring the load for a dome to the wall at the corner, the columns at the corner. So these 2 points can easily transfer the load through the curvature to this point here. That's what the role of a pendentive is. So we can have a three-dimensional curve like we see here. So three-dimensional curve can be added on the corner instead of the corners. That will help us in reducing the surfaces. So this is the three-dimensional curve that gets added on the sides. So the total number of surfaces, we have 6 surfaces, 6 faces, so 6 faces, plus there will be 4 pendentives on top, 4 pendentives on the bottom. So 4 plus 4, it comes to a total of 14 pendentives. The correct answer is option B here. Okay, we'll move to the next one. Sheetal is running. Which option denotes the most natural pose of a running person? Okay. So because when you are running, we always alternate our hands and leg. So when I say alternate, what I mean is if hand is leading, the leg is at the back. If leg is leading, the hand is at the back on the left side or right side. So correct answer here is option C. We'll move to the next one. Tile X was used to create a seamless pattern when arranged as shown below. Which tile or tiles from the options will create a seamless pattern without any gaps? Okay, one or more options are correct here. So this is how the repetition can happen, where option A will have these triangular gaps happening, so it's not possible. Option B also has these gaps happening, so even that is not possible. Option C and D are correct, which creates this kind of a seamless pattern. Okay. We'll move to the next one. Which of the options on the right can be formed by folding the profile shown on the left? We are given here a profile. We have to identify which of these options on the right can be formed here. Okay. Now, given the options, we have two faces with green colored cross and two with yellow. We'll first take the green colored cross, which is this and A and D. In the green colored cross, the bottom is yellow, which means that it is the exact same orientation where this forms the base here. Okay. This is the base for option A. From that, we have red and blue colored one on one side, and on the other side we have green, and then immediately after that blue color we have a green color. Now, if you observe that red, blue, and green are happening on the other side, they are happening here, and then the green color fits here on this side. Okay, this fits here. So actually that is happening on the right side and not the left as shown here. So A option is wrong. Now we'll go with option D with the same face, green colored and green at the bottom. Green colored and green at the bottom, which means this is the place which will be the base for option D. Okay, green color यहाँ पे stick होगा, that's why. Then you have blue and red, which is fine. Yellow happening here, not a problem. And then orange also happening here. Sorry, orange also happening here, not a problem, which is this one. So it's correct, no issues with it. Option D is fine. B and C. B and C may you have the yellow color happening here. Okay, yellow is the front. So when yellow is the front, yellow at the bottom. Yellow at the bottom, which means this is your base for option B. Okay, yellow at the bottom. Orange and blue are fine, and then green is also fine. Yellow भी ऊपर आ जाएगा आपका यहाँ पे ये जगह पे, so even that is fine, and orange on the bottom here also works. So B is okay. Option C. With case of option C, the bottom being green, which means this is your base. Okay, for option C, which means that orange color वाला जो है आपका वो आपका left side आ जाएगा. So this will be rotated as a base. This comes on this side. Orange on the vertical, this vertical happening here, and this at the bottom also works. So correct option C is also correct. Correct answer is B, C, and D. All three are correct. We'll move to the next one. In a 3D structure made of cubes of equal size, an L-shaped hole is made by removing a few cubes, as shown in the image on the left. Which of the 3D structure in the option on the right would successfully pass through the L-shaped hole, given that they all are made of cubes of same size? Okay, so we are given here a hole. We have to identify which of these 3D will pass through the hole. The hole, if you observe, is a 3 by 2, 3 units, 1, 2, and 3 units, and then 1 and 2, 3 by 2 unit hole. So A, if you look at it from this side elevation, you will get a 2 by 2 structure. So a 2 by 2 structure can easily pass through this hole. So A is fine. Next, with case of option B, again from the same side, I get a 3 by 2 structure. So again, the 3 by 2 structure can easily pass through the whole hole, no problem, from this side. Option C may be again from that side, we get a 3 by 2 structure here. ये elevation यहाँ पे आ जाएगा. So even C works, no problem with it. Option D वाला जो है, in that case, you have a T junction getting formed. We have a T junction getting formed like this. In the case of a T junction, what will happen is, first we will pass the T completely. We'll pass this up till this part completely through that. After that, from that, we will actually shift at the bottom. We'll actually shift this piece bottom like this. And then allow the remaining two parts to move through. So correct answer also is D. Correct answer is A, B, C, and D. All four are correct here. We'll move to the next one. Figure below shows six bar charts corresponding to the volume of agriculture produce from farms of various farmers. The actual quantities are also shown in the red. Inside in the figure, red bars indicate tomatoes, green bar indicate leafy vegetables, and blue bar indicate berries. Assume that they have seen each other's bar chart. Who can correctly make at least one of the following statements? First statement says, everyone who produce any one item more than what I produce, she also produce every other item more. Second statement says, everyone who produce one item less than what I produce, she also produce at least one other item less. Okay. Now let's look at the first statement. Everyone who produce one item more than what I produce, she also produce every other item more, which means we have to find one lady farmer who is producing the least out of other. Only then she can make this claim that everyone, sorry, not anybody, but everyone who produce one item less than what I produce, she also produce every other item less. Sorry, every other item more. So this person has to have the least produce. The least produce is Sukanya or Sunita. If I look at Sunita as a reference, 20 and 20 is the least number, but then here 20 equates with berries. So that does not work. Also this 60. See, 60 is actually not the least because you have 30 and also 20 for green leafy vegetables. So Sunita cannot make that claim. Now let's look. So first claim cannot be made by anybody actually. Forget Sunita, but nobody. Now let's look at the second claim. Everyone who produce one item less than what I produce, she also produce at least one other item less. From the options given below, yes, we can say that let's start with Vinita first. So Vinita, can she make this claim? So when you compare Vinita with Nali, we'll find that red tomatoes are equal and one item less and at least one other item. So this is green leafy vegetable is less, but then 30 and 60, this is more. So this does not work out. Okay. Nali, Vinita does not work out. Next, we check for Priya. Priya is this as a reference. Yes, compare Priya and Vinita. One item less, Vinita with tomatoes works, no problem. Leafy vegetables is equal and this is less. So we do have one item less here, but not other item less. So Priya also does not work. Now let's look at Neela. Neela is here. Neela, she is 60. So let's compare it with Vinita. So 60 less than 40 works. ये कम है ये भी कम है और 60 and 30 this also works. So Neela and Vinita are fine. Neela and Nali, when you say one item less is this and then another item less is this, and this is equal, but these two works, no problem. Neela and Sukanya, this is less, but this is also less, so it works. Likewise, Neela and Priya also works, where this two works, and then Neela and Sunita, even these two works, and even this works. So Neela can make that claim. Now let's check for the second claim with Sunita. When you talk about Sunita, this one, there is one item less, every other item less. That's fine, not a problem. The issue that happens is with when you compare Sunita with Nali. So this is more, tomatoes is more. ये वाला कम है, so this works, and then this is more. So Neela and Sunita, Nali and Sunita, they don't pair up. So even Sunita cannot make that claim. The correct answer here is option C, Neela. Okay. We'll move to the next one. The figure shows 4 road networks. Which of these road networks can be traversed by a traveler such that the following challenge can be satisfied? The traveler must cover all the roads in the network. She is allowed to visit a city more than once, but she is not allowed to travel on any road more than once. Also, the traveler must come back to the city where she starts. Okay. So let's start with option A. So what are the conditions? We have to travel through all the roads. We can travel through a city more than once. We are not allowed to travel to any route, okay, more than once. We have to cover all the road networks, and the traveler must come back to the city where she starts. So Let's take the most connected road, which is, say, Indore, for example. Here, option A. Mathura, Agra, Delhi, Roorkee, Agra, Jaipur, and Indore. But in that case, we are losing here and this route, so A is not possible. Option B. Let's start with Aurangabad. Aurangabad, Nashik, Mumbai, Ratnagiri, Mumbai, Pune, Satara, Ratnagiri, Pune, and Aurangabad. It satisfied all the conditions, so B is fine. Let's start with C. Salem, we start with. Bangalore, Mysore, Bangalore, Chennai. Then we go to Trichy, Salem, and then we can go to Chennai and stop. We cannot go back anywhere else. So C does not work. Then let's go with option D. We start with Kolkata, Guwahati, Gangtok, Darjeeling, Kolkata, Patna, Puri, and then Kolkata back. We are satisfying all the conditions here. So correct answer is B and D, both. We'll move to the next one. The grid of square shown in the figure is to be tiled with tiles shown in the options. The covering tiles must not overlap and should not have any gaps around them. Only 4 squares and tiles in the middle are to be left out. Once a tile is chosen, other tiles must be of the same type only. Tiles can be flipped and rotated if required. Which of the tiles can be used to tile the given grid? Okay. So here, I first start with the assumption that instead of taking each and every tile, we start with the assumption is how we can tile each and every part. So what I came to know was that if you are tiling it as a 4x2 grid module getting repeated across, a 4x2 module getting repeated across, we are covering all the spaces without any gaps or overlaps. So we'll identify which of these can make that. So A does not work because it creates a 3x2 module. There will be gaps in between here in these spaces. So A is not possible. B will create a gap at the corner here itself. So maybe these kind of corner places won't be possible. So B is wrong. C creates a 4x2 module, which is here seen. So it will fill the thing completely. And D also creates that module. So D is also fine. C is also fine. So correct answer is C and D here. Okay. With this, I will end today's session here. Thank you so much for your time, guys. And guys, if you like this content, please do share, like, share, and subscribe. And please forward it to the people whom you feel it will be useful to. Thank you, guys.